This module is an intermediate step to get ready to build our future microservices. We will learn about a few new tools that will help you as you start working with more microservices. And we will build a useful library that we will use in future models. Here's what you will achieve after finishing this module. You will learn how to use Postman as an alternative to Swagger UI to interact with your microservices. You will generalize the items repository so that it can be used with any future entity. You will create a NuGet package where you will place all common classes that you would like to reuse in future microservices. And finally, you will use Docker Compose to simplify how to run MongoDB and the multiple infrastructure services to be used in future models. Let's get started. In this lesson, we will learn about Postman, which is a popular API client that we will be using starting with this module. Postman will allow us to interact with our microservices REST APIs without having to open a browser to navigate to the Swagger UI page of each of the services. In addition, it will offer us a few additional capabilities that will prove useful across this course. The only additional tool required starting with this module is the Postman client, which you can get at this location. Let's get started. Let's go ahead and install Postman. I'll go to the Postman download page at postman.com/downloads. And here I'll just scroll down a little bit. I'll click on download the app. I'll pick my operating system, and that will start the download. In the same way, depending on your operating system, you can choose the Mac OS or Linux version. This should take just a few seconds. Okay, so it's downloaded. I'll click on the installer. And yeah, the way that the installer works for Postman is that it will just pop up this screen here. So it's already installing the application. It will take a few seconds, and then the Postman UI will just pop up in your screen. Yep. And here it is. And so at this point, you have the option to create an account with Postman if you want to keep track of your collection, settings, and a bunch of things that you may be interested in. But in our case, we really don't care about that at this point. So I'll just click that link at the bottom side here, skip signing in, and take me straight to the app. So I'll just click on that. And then we are in the Postman user interface. The first thing that I'll do here, just because I don't like this theme at all, so I'll just go to settings over here, settings, themes, and then I'll switch to the dark mode setting. Okay, so now that we have Postman available, let's go back to our catalog service in VS Code, and let's start querying for its several APIs. So I'll minimize this, I'll close this browser, and yeah, here we are in the catalog service. And then, yeah, I'll just do F5. All right. So as usual, the browser opens, but this time we're not going to be using the browser. We're going to go straight into Postman over here. And here, what you can do to start querying your REST API is if you have the Launchpad open, like me, you can click on Create a Request over here. Or if you don't have it open, you can click on this plus button to open a brand new tab. In this tab, what you want to do, the first thing you want to do is figure out which is the verb that you're going to use for your REST API. If you click on this dropdown, you're going to find a bunch of HTTP verbs for the different operations. So let's say that we want to start by doing a get. So I'll click on get, so that we want to get the list of items in our catalog API. So then you want to type here the URL of the REST API. And if you don't remember the host where you're running your web server, you can easily find that out by going back to Visual Studio Code. And here you can find that that URL either right here in the debug log, where it says now listening on, is right here. Or you can also find it if I scroll down this a bit, and then you open properties, launch settings.json, is right here close to the bottom, where it says application URL is over here. So HTTPS localhost 5001. So I'm going to copy that and back into Postman. And so I'm going to paste that over here. And then what you want to do is add the route for our controller. So once again, back in Visual Studio Code, if you open controllers, items controller, you're going to find our route right here. So route is items. To copy that, back into Postman, and I'll say /items. And with that, you can just hit send, and that's going to query the REST API. Now, if you get an error like the one that I'm getting down here, which says SSL error, unable to verify the first certificate, this is actually expected. It's a default verification for the certificate of your web server. Since we are using a self-signed certificate that comes bundled with ASP.NET Core, that's not really a friendly certificate for Postman, but it is okay to get past that verification because it's just a local web server for development purposes. So what I'll do is I'll just click on disable SSL verification. And that's going to go ahead, I'll just close this, that goes ahead and queries the REST API without issues. Of course, we don't have any items available in the database right now, so that's why we see an empty array over here. But we can actually try out to create a brand new item. And to do that, what I'll do is I'll click on the plus icon over here, which opens a new tab. And I'll switch from get into post. And once again, I'll paste our entire route here. So I'll copy from get, I'll paste it here in post. And then what we want to do is go to the body section over here. And we want to choose raw. And at the end of this section, I'll pick JSON. So I'll open up this. And here is where we can define the body that we want to send to this post request. So I'll open up a section, a JSON section here, and I'll start typing the elements for creating, in this case, an item. So if you remember, the elements are a name. So we need a name. And let's say we go back to our potion example. So I'll just say potion. Then we need a description. So description is going to be restores a small amount of HP. And finally, we'll set up a price, which is going to be, let's say, 5. Okay, so with that done, I'll do this. I'll go ahead and hit send. And as you can see, the item has been created. Okay, we have an ID. And if we wanted to, we can now go back to the get tab here, and we can query for items once again. So I'll click on send, and now we can get items. So just like this, you can keep going on and using the rest of our REST API operations by opening new tabs and opening and using the different verbs over here. However, each of these times you'll have to remember what to put exactly on both on the URL and, in the case of post, for instance, the body and the elements that you want to use for the payload to send in that body, right? So what if you don't remember exactly what to put in all of these cases? So what I'd like to do is just show you another way to do this to simplify a little bit this overall process. So what I'll do is I'll just right click here and I'll close all tabs. So actually I'll say cancel. Let me close this, don't save, close that. So one thing that you can do if we go back into our browser over here is we can go ahead and find the OpenAPI specification for our API. So if I go to /swagger, hit enter, we're back into our Swagger UI page, but this time we're not going to use any of these methods. What we're going to do is click on this, if you can see this swagger.json link over here. I'll click on it, and this opens the OpenAPI specification. So this describes the entire REST API in a standard way. So what I'll do is I'll copy this entire URL, and then I'll go back to Postman, and I'll go into the import button over here. I'll click the link section, and then I'll paste that URL over here. Click continue, and finally I'll just say import. And now if we go into the collection section over here, you're going to see that now we have a description of our Play Catalog service listed here with all the requests. So if I open this, and there's the items route, and if you open that, you can see that we have routes for get and for post, and also if we want to go by ID, we can go ahead and get an item by ID. We can do the put, which requires an ID, and we can do also the delete. So this time, if you wanted to get all items, what I can do is just click on get items, and then that's going to open a tab with an already filled in verb and URL to go ahead and request the items. However, you're going to notice one new thing here, which is the base URL. So the base URL represents really the root of your, or where you're hosting your REST API at this point. So this is the localhost 5001 section. So Postman just doesn't know that information just yet. It just knows about the routes and the payloads. So to fill in this variable here, base URL, what you can do is go back to Play Catalog Service over here, click on these three dots, click on Edit, and then you go to the variable section here. And then you want to put a value for current value. So what I'll do is I'll just put HTTPS localhost 5001. Okay. I'll also put that in initial value. This is what somebody else that wanted to reuse your Postman collection would have as an initial value if they wanted to. So I'll just keep the same value for both of them. So then I'll just hit update. And now if we hover over base URL, you can see that now we have a result value being popped up there for our REST API. So now I can go ahead and hit send. And once again, I get my items. But more interestingly, if I wanted to do a post this time, I can click on post. And then again, the URL, the verb is filled, the URL is right there, and the body is already pre-populated with all the elements required for this API. Let's actually try to do a put. So I'll go ahead now into put. And again, the URL is pre-filled in there. What we want to do is to, in this case, first we need the ID of the item, which we can get from the Get Items tab here. So I'll just copy that ID, back to put, and I can put the ID right there. And then in terms of the body, I can go to the body section, and like I said, it is pre-filled, so I just have to put the elements for this body. So I'll actually just copy those elements from here. Okay, and then I'll do proper indentation. And so here's where we can go ahead and update something about this potion. So I'll just update the price again. So I'll say 7. And then we're going to click on send. And we got a response, 204 no content, meaning that it succeeded. And so now we can actually try, let me copy the ID of this item. We can try our get by ID API. And then again, the URL is pre-filled. I'll just paste the ID over here. I'll hit send. And there it is. We got our potion. So as you can see, it is pretty handy to just import the Open API specification into Postman and be able to very quickly start working with your REST API in Postman. Now, a few other things that are available in Postman as opposed to our previous Swagger UI page is things like, for instance, of course, we have the concept of these collections, which in fact you can actually export if you wanted to and share this with somebody else in your team or some of your teammates. You can easily export this collection. And you will do that by clicking on these three dots, and you can click on export, and there's going to be a few options for you to export this for somebody else. Then also you have this tab over here that says history. This will show you the history of all the previous invocations of your REST API. So if you wanted to go back to something that you did in the past with the specific payload that you did and URL, you can do that. So this is going to keep a long list of all the queries that you made to your REST API across your different sessions. There's also this concept of environments over here, which you can use to define the different environments where you want to invoke your REST API. So if eventually you're not just running in your localhost machine, but perhaps you have deployed this to some cloud environment, you can define variables over there so that you don't have, so that for instance, the base URL automatically changes as you change the environment that you're specifying over here. That way you don't have to keep opening more and more tabs for the different environments. There's also the ability to specify authorization options over here for the different authorization types, so that you can, for instance, generate and use authorization tokens to call your REST API if your REST API is enabled for that. That's actually something that we will look at in a future model. Okay, so now that we have done that, one more thing that we want to do is to, since we are now going to be using Postman, we don't really want to be opening browsers all the time. So how can we prevent the browser from keep opening every single time. So I'll have to just go back to the browser and I'll just click close this. And then I'll go back to Visual Studio Code. And well, I'll stop and close this. What you can do is you go back to, we go to Explorer, and we're going to go to .vs Code, launch.json, and you want to look for this section that says server ready action. So this section here is the one that Visual Studio Code uses to define if they wanted to open a browser after something happens with the web server. In this case, it's just looking for the message that says now listening on. So when it finds that, it knows that it needs to open the browser. So in our case, we don't want to open browsers anymore. We'll find with Postman. So we're just going to remove this section, delete. And now if I do F5, okay, no browser is going to open. We just stay here. But as always, you can just go to Postman and start querying the API like we already did. Okay, so that's it for this lesson. And in the next lesson, we will start extracting a few of the classes that we are using in Catalog microservice into some shared components that we can use in our future microservices. In this lesson, we will learn about the need to reuse common code across microservices and how the NuGet Package Manager can be used to package and share code across services in a straightforward way. One of the things that you will likely realize as you start building more than one microservice is how much code starts getting repeated between each service implementation. For instance, our Catalog microservice currently has a repository implementation for querying and storing data in its MongoDB database. It also has a couple of settings classes to more easily use the different service configurations that are stored in our app settings.json file. Eventually, we will also add classes to interact with our service broker, code to add instrumentation to the services, and likely some more code that is not directly related to the purpose of the microservice. The problem with this is that as soon as we bring in our second microservice, the inventory service, we would likely need to copy to it that same code with very little modifications. This is time consuming and goes against the don't repeat yourself principle, which states that every piece of knowledge must have a single, unambiguous, authoritative representation within a system, which in our case means that our common code should live and be maintained in a single place. Therefore, we could be tempted to keep our common code in one of our microservices and have all the other services simply reference that project to get access to the common code. However, this is not a good idea because microservices should be independent of each other to ensure each of them can evolve quickly and have no ties to the internal implementation of others. We can solve this problem by introducing a new library project that we will call the common library, and then we can extract all the common code into it. The common library becomes the single place where we have all the code that is not specific to any microservice, and therefore is the single place where we will perform any updates to it when needed. But then, how can we make the code in this new common library available to our microservices? We could have our microservices add a direct reference to the library project file. But that's not a good idea because as new members join our team, each of them might want to work on one microservice or the other, or even in the common library, and therefore they will only grab the code base for the project they are interested in, but not the code bases of all projects all the time. Plus, eventually, each microservice and the common library should get their own independent source control repository where they can be tracked and built independently. So, if the microservice projects can't access the common project directly, what can they do? Here is where we can use NuGet, which is the package manager for .NET. With NuGet, we can execute a simple command like .NET Pack to bundle all the output files from the common project into a NuGet package. A NuGet package is nothing more than a zip file with a NuPKG extension that contains all the files that are to be shared with other projects. Now, each of our microservices can reference the NuGet package to get access to everything that the common library has to offer. And the good thing is that microservice projects don't need to know where these NuGet packages are hosted. We will initially place the package in our local machine, but eventually you will likely want to host them in a cloud-based location, either accessible just by your team or by anybody on the web. The important thing is that regardless of the location, you won't have to change how the microservices access the common code. With our new common NuGet package, our common code is now maintained in a single place, and the time to build new microservices is significantly reduced. In the next lesson, we will extract our current common code into a new common library, and we will produce our first NuGet package that the catalog microservice and every future service will be able to reference to get quick access to the common code. If we take a look at our items repository class over at repositories, items repository, we will notice that there's a lot of code here that we will need to reuse in future microservices. And the same goes for our settings classes over in the settings directory, MongoDB settings, service settings. We can certainly reuse these in future microservices. But before we can move anything to a new shared library, we will need to do some good refactoring to keep the generic pieces separated from what's really needed in the catalog microservice. So let's start by looking at our items repository. And if we take a closer look at what's going on here, there's one piece that's really repeated a lot across this class, and that is the use of the item entity. The item entity is being used in several cases, like for instance in getAllAsync is being used to return the items that are going to be queried. And we are also filtering by the ID of this item in both in getAsync method and also in the updateAsync method. We'll filter in by ID and also in the removeAsync method. So we need to find a way to generalize the use of this entity so that it can be used in, like I said, in a more general way in this repository. So let's actually go to the item entity. So right click, go to definition. What we're going to do here is to actually extract an interface out of this item class to narrow down the pieces that we really need to generalize about the item. So what we're going to do is just click on the light bulb and say extract interface. And now we have the item interface here that our item class is implementing. However, we don't want to call this interface item. We actually want to call it iEntity. And this iEntity is what our item class is going to implement. But also, we don't want to have all these properties in the interface, but only the ID. Having the ID will be good enough to be used in the repository class that we're going to implement. Now, we also want to move this interface into a different file. So I'm going to click on the light bulb, and I'm going to move the type to iEntity.cs. Okay, so now we have the item entity that implements iEntity that is in the iEntity.cs file over here. Now what we're going to do is before going back to the items repository, let's go to the items repository class and see how we can generalize this. So to start with, we don't want this class to be about just items anymore, but about a generic type. And the way that we can do this is by renaming this interface into, instead of iTems repository, it's going to be iRepository. And it is going to be of a generic type that we're going to just name T, where T represents the actual entity that's going to be used in a specific microservice. So this T, we'll add a constraint here, where T has to be and iEntity, the interface that we just defined. So whatever we use for T, it has to be a class that implements the iEntity interface. So now that we have that generalization, we can say that all of our methods actually use this T type. So for instance, instead of having item here, we're going to name it as T. And the same way we're going to do for the item that's going to be returned in getAllAsync, the item that's returned in getAsync, and also the item, the entity that's received in updateAsync. Okay, so with that, there's no longer a mention of the item type anywhere in this interface. So with that done, we can now go back to our items repository and also generalize it to represent a more generic repository. So instead of being an items repository, this is now going to be a Mongo repository that is going to be of some type. So again, we're going to use type T to represent the actual entity that's going to be managed by this repository. And also, our repository class now needs to implement the iRepository of T interface. Again, where T is an I entity. Okay, so let's also rename the constructor to be Mongo repository. And let's start changing this so that it actually, to start removing everything related to item from this class. So one of the things that we have to get rid of is this constant that is the collection name, items. Since this is not going to be just about items anymore, let's remove it. And what I'm going to do is just copy collection name, just the name of the constant, and remove it. And now we are going to receive that collection name as a parameter in the constructor. So we're going to receive string collection name. So that's a collection name that's going to be used when we try to retrieve a collection from MongoDB from here on. Okay, and so now we need to start moving forward and start generalizing things. So let me just get a copy of T. And so anywhere where we find item, we want to replace it with T. So this is a DB collection of T, filter builder of T, builders of T that filter. And we get a collection of a T entity. When we do get all async, we have to do T again. And again, when we do the filtering, so get async of T over here, it's all generic. Also create async should be T. Update async should be also T. Filter definition of T. And notice that since our interface has the ID property, it doesn't really care that it doesn't know what's a real item, as long as that the real entity, as long as that entity implements iEntity, it is able. We know that there's going to be an ID property, a GUID ID property that we can filter by. And finally, let's change our remove async to also deal with just with T. All right. So just to confirm, let's make sure we don't have item anywhere in this file anymore. Yep, there's no more item here. So let's also rename the file, by the way. So this should be Mongo repository. And this other file here should be iRepository. And with that done, it is time to start fixing all the references to our repositories. So let's start by going to our controllers class, items controller, and let's fix things, right? So this is no longer an iAtms repository, it's just an iRepository of type item. And that is what we are going to be receiving in the items controller, in the constructor here. Okay. Next thing that we need to do is to fix the way that we are registering the repository in Startup. So let's open up Startup and let's see how we are registering the repository over here. So this is what we're doing today at singleton iAtms repository, items repository. So we will switch to a more concrete way of defining this singleton, because now we need to specify a parameter as an input to the repository. So remember, in Mongo repository, now we are receiving a collection name. So we cannot just expect all parameters to be injected automatically by the service container for us. So we need to be more explicit. So let's update the repository registration. To start with, we are no longer using the iItems repository interface. We are using iRepository of type item. And let's see if we're missing something. So let's add the service entities namespace. So it's an iRepository of item. We will not be specifying an actual class as a second parameter here. And then we have to specify the service provider. Service provider, just like we did in the other at singleton call. So open braces here. And now, before we can create the instance of the Mongo repository, first we need an instance of the iMongo database. Because remember, we actually registered an iMongo database in the previous at singleton call. So how can we get an instance of such a registered service? So that's where you can use the getService method of the service provider. So just like this. So var database equals service provider that gets service iMongo database. Okay, so anytime that you need to get an instance of a service already registered in the service container, like we did with iMongo database, you just need to call get service on service provider, and this will work as long as that service has been registered before the call that you're going to make here. And then having that iMongo database instance, we can now return our new Mongo repository of type item. And then we need to provide two parameters. The first one, the database, the one that we just got, and then the collection name that so far is been just items. Okay, so that should do it. Let's make sure everything is building successfully. So I'll do Ctrl+Shift+B. And indeed, everything is building just fine. So at this point, we have generalized our repository class so that it can be used with any type of entity. However, it feels like we're writing too much code on startup to register the MongoDB related classes, because look at this. We have to do register serializers. We have to do the singleton registration for the Mongo client, for the Mongo database, and then the other singleton for the repository. So in the next lesson, we will introduce a couple of hand extension methods that will simplify things quite a bit for this and for future microservices. So let's take a quick look at everything that we have to do in order to use our Mongo repository so far. So here I am in the startup class, and the first thing that we have to do is register the Bison serializers in order to change the way that we store GUIDs and datetimes. Then we have to get the MongoDB settings, the MongoDB settings section from app settings.json in order to construct our Mongo client. And then we can create our iMongo database that we registered as another singleton. And then finally, when we have that, we are able to retrieve that iMongo database and then construct our Mongo repository for the items collection. So let's see how can we simplify all these lines to make the life of future microservices much easier. What I'm going to do is create a new extensions class inside the repositories directory. So I'm just going to right click here. I'm going to create extensions.cs. Not to be confused with the other extensions that we have over here. This is a new class. Let's give it a namespace. Play catalog service repositories. So let's name this class public static class extensions. And let's declare a function here. So it's going to be public static iService collection, because we're going to be extending iService collection here. And let's name it @Mongo. And it's going to receive, or it's going to extend the iService collection object. Okay, so it receives iService collection and it will return an iService collection. Let's see if we're missing a namespace. So let's add the dependency injection namespace there. And here, let's go ahead and grab a few lines from startup. So let's grab these lines over here. And let's go ahead and add missing namespaces. So I'll do Bison serialization. I'll do serialization serializers, and then MongoDB Bison. Okay. And then we will need service settings, but we will not receive them here. We will get them over here as a var service settings. But one thing that you can notice is that we don't have an instance of configuration here, just like we had in startup, where it was a property that we received as part of the constructor. So what we can do is use a service provider to explicitly request an instance of a service that has a variable register. So configuration is registered already by ASP.NET Core Infrastructure, so we should be able to request it at this point. What I'm going to do is just say var configuration is service provider.getService. And the type of service is going to be just iConfiguration. Okay, which needs the extensions configuration namespace. So now we can flip this configuration into just configuration with small caps C. And then we are also missing another namespace here, which is a service settings namespace. Okay, so we get the configuration, we retrieve service settings, MongoDB settings, we construct the Mongo client. Let's add the missing namespace here too. And that allows us to return the iMongo database. Finally, we're going to return the services collection just to enable the fluent use of this extension method. So that will register the iMongo database instance. And now let's add another method to register the repository itself. So I'll open up another method here. Let's call it public static iService collections, going to return at Mongo repository. It's going to be the name. And then we'll specify a constraint of T for the actual entity type that's going to be used. And then it's going to extend iService collection. The name is going to be services. And then remember, we have to specify a collection name in order to create a repository. So let's receive collection name as a parameter. We also need to specify a constraint for that for that T parameter. So T, the T type that's going to be used, has to be a type that implements iEntity. Okay, so we may need another namespace. Let's first expand this. Save it. Let's send this to the other line. And let's add the service entities namespace. Okay, so this will be useful to register a repository with any type of entity, but that entity has to implement the iEntity interface. So now what we can do is go back to startup and grab these few lines for the iRepository registration. We'll copy that here. And then to make it generic, we're no longer going to be using item here, but just T. And then this also registers as T. And we no longer hard code the collection name. We're going to be using the collection name parameter. And finally, to keep it fluent, we return services once again. So with that, we should be ready to start using this extension method. So let's go back to startup. Okay, so we're going to go ahead and remove this serializer registration. Let's skip service settings for now in case we need it later, but we definitely don't need any of this stuff. So now what we can do is just say services at Mongo that registers our Mongo client and the iMongo database. And then since this is fluent, we can say at Mongo repository. We need to specify a type. In our case, type is item. And then we provide the name of the collection, which is still items. So with that done, let's just make sure things are keep working properly. So I'm going to hit F5 to start a web server. And I'm going to go into Postman. And I'll do, again, our simple get all items request. I'll hit send. And yeah, it keeps working just fine. But as you can see, the code in startup is way simplified. In the next lesson, we will see how to move all of these common classes into a new shared library that can be used by all of our microservices. It's time to move the common code we refactored from our catalog microservice into a new shared class library that can be used by both catalog and any future microservice. So to start with, I have opened here a brand new instance of Visual Studio Code. And what I'm going to do is just go into File, Open Folder. And once again, I'm going to go into my D drive and into Projects. And here I'm going to create a new directory. I'm going to call play.common. Then I'll go into that directory and I'll select folder. So this opens Visual Studio Code in the context of this play.common directory. And now I'll go over here at the top and I'll just click on new folder. And this is going to say SRC. And I'll right click SRC and I'll say open in integrated terminal. Right? And now we're going to use this terminal to use the .NET CLI to create our brand new class library. So to create a class library, what you can do is .NET new class lib for class library. And then let's give it a name. And the name is just going to be play.common. Hit enter. All right. And so at this point, we have our new files over here, as you can see. And the first thing we're going to do is go into the project file. And just like we did with the cataloging service, we're going to be removing a couple of these settings that we're not going to be using for most of the course. We're only going to review once again at the very end of the entire program, right? So implicit usings and nullable just goes away. We're not going to be using that, but we stick to .NET 7, right? We always stick to .NET 7. Then, just like with any other C# project, we have to make sure that the OmniSharp project server is up and running so that it can provide us all those productivity tools while we work on C# files. So to do that, all we have to do is just click on the class.cs. And so by doing that, as you can see down here, the OmniSharp server has started. We see a little file over there. And we have our bin and obj directories over there. But in this case, we do have to inform Visual Studio Code that we need to generate those additional files, the task.json file, so that we can build the code directly via Visual Studio Code. So to do that, since it didn't do it automatically, what we can do is just go into Ctrl-Shift-P to open the command palette. And then we can select this .NET Generate Assets for Build and Debug option. You can also type that. If it doesn't show for you, it's just .NET Generate Assets for Build and Debug. So you click on that, and it will go ahead and generate our now familiar VS Code folder right there. And that has the task.json file that we know that we need for the build task that's defined here, that will allow us to now do things like use Ctrl-Shift-V, and it will go ahead and build the code for us. Right? And so I'm going to kill this terminal right there, and I'm going to close all these files. And also I'm going to delete this class1.cs because we don't need it. We need that file. I'm just going to go ahead and delete that. And now it's time to add a few NuGet packages that our shared libraries, our shared classes are going to need. So first I'm going to switch to play.common. Here I'm going to start adding a bunch of packages. So I'll do .NET add package, MongoDB.driver. Okay, so that's for MongoDB. Now we need a couple of packages for the configuration related classes. So .NET add package, Microsoft extensions, configuration. Okay, we'll do that one, and configuration.binder. And lastly, we have to add the extensions.dependency injection and NuGet package, which is going to be used for everything related to the service container that we're going to be using for dependency injection in this library. With that done, let's go ahead and start creating folders to bring in our files. So the first folder I'm going to create, right click in play.common, new folder. The folder is going to be settings. And here's where we're going to place the settings files that we have in catalog. So I'm going to go back to catalog folder, the catalog directory, right here. And I will open settings, and I'm going to copy these two files, MongoDB settings, service settings, copy. And back in common, I'm going to paste those files here. And I'm going to close the terminal for now. And now that we have them here, let's fix the namespace so that it matches our current project. So this is going to be play.common.settings. So both for MongoDB settings and for service settings. Okay, with those files done, let's go back to catalog and let's bring in our identity interface. I'll copy that. I'm going to place it just at the root of play.common. Identity. And let's also bring our iRepository interface. iRepository, copy, into play.common at the root. Okay, so these two should have also the namespaces fixed. So they're just going to be in play.common. So play.common, that one, and play.common on this one. Let's also get rid of any unneeded namespaces like this one here. Get rid of that one, and we're good. Now I'm going to add a new folder for our MongoDB related classes. So I'm going to create a new folder here in play.common called MongoDB. And in this folder, we're going to add, let's go back to catalog. We're going to add the extensions file and the Mongo repository file. Copy those ones, back in common, MongoDB, paste. So for these ones, the namespace is going to be play.common.mongodb. And on this one, again, play.common.mongodb. I'll also remove any unneeded namespaces from here and from here. And in the case of extensions, we also need to tell it the new namespace for the settings files. So I'll go to service settings, control dot, and I'll use play.common.settings. Okay, so now we have all of these common classes in our new common project, and that should be good to start building our NuGet package. But since we are here, let's actually take advantage of the opportunity to expand a little bit our Mongo repository class with a couple of new functions that our future microservices are going to be using for querying entities based on a filter. So let's go ahead and go to our iRepository interface. So let's start here. And what we're going to do is add a couple of new functions similar to our overloads to get all async and get async, but that are going to be able to receive an expression as a filter to filter which entities are going to be returned. So let's start by get all async. I'm just going to copy this function. I'll add a new one here. And the way that we're going to specify the filter is going to be via an expression, a link expression. So it's going to be an expression. Let's add a missing namespace, link expressions. And the signature we're going to use is the one that MongoDB is expecting from us. So it's going to be a func of type T, so whichever type is the entity, and bool filter. Okay, so again, so this is the way to specify a filter so that eventually when we want to retrieve entities based on some feature, let's say, give me all the items that are owned by a specific user, in the case of inventory, we will be able to use such a filter here. So you can pass a query expression here, and then MongoDB will be able to handle that filter and return the correct items for us. The same way that we did that, let's go ahead and do get async, another overload that is also going to receive expression. So in this case, you don't need to specify just an ID to get one item or one entity, but you can specify a filter to retrieve any entity that matches that filter. Yeah, and when we get to our new microservice, our embedded microservice, we'll see how both of these functions can be used. So now that we have that in the interface, let's now go to Mongo repository and actually implement these new methods. So I'll go ahead, I'll click on iRepository, control dot, implement interface. So that brings in our new methods at the bottom. I'm just going to relocate them next to their other overloads just to keep them close to each other. So I'll put that there. I'll grab get async and I'll put it next to our other get async overload. There. And really this is very straightforward. So what I'll do is I'll copy the last line of our other other get all async method. I got here this line, and I'll copy it to our new get all async overload. And really the only thing that we have to do is pass the filter there. Because let's see, if you go to find, you're going to see that it can receive a filter definition, but in another overload, it can receive an expression of the type that we have defined. So that's the overload that we're going to be using from MongoDB to be able to filter. So I'm just going to pass the filter here. And I'm going to make this method also async. That will be enough to retrieve all the items based on a filter. And for the other overload, the get async, again, I'll copy the code from the other overload over here. And here, the filter is already there, so it's ready to receive the filter, but let's make it async, and that will do it. So we can retrieve one entity based on specified filter. And like I said, these methods are going to be very handy as we move to the future microservices. So with that done, let's go ahead and build everything, make sure everything is built in correctly. So I'll do Ctrl+Shift+B. Okay, so everything builds just fine. And what I'll do now is I'll switch to my PowerShell terminal so that we can create this NuGet package. And how do you create a NuGet package? Very straightforward. You just use .NET CLI with the .NET pack operation. So we will do .NET pack. And then you have to specify the output directory with -o. And then given my current file structure, what I'd like to do is to place the package in a packages directory under the dprojects folder. So what I'll do is -o // I'll go up 3 directories and then I'll specify packages / and that should be enough. Hit enter and that's it. The NuGet package has been created under the packages, and we can confirm that by going to here. We have a packages directory now, and if I go to packages, the package is right there. So this package contains everything compiled out of our play.common library. So now it's time to go back to catalog and start using this new NuGet package. So I'll switch to catalog. Here we are. And before we can get a reference to that, to our play.common NuGet package from catalog, there are two things that we have to do. The first one is to specify a NuGet package source for our current NuGet installation. So remember that NuGet packages can live in multiple locations. They could live somewhere in your intranet. They could live somewhere in the cloud, in a public location like NuGet.org, or in a private feed library, or they could live in your local machine, as it is our case. But NuGet doesn't know about that. So you have to tell your NuGet installation which are the possible package sources where it can find the NuGet packages. So we're going to tell it right now that our NuGet packages are in our dproject package location. So to do that, I'll open our terminal right here. And what I'll do is I'll use again .NET CLI with the .NET NuGet command, .NET NuGet add source. And here I have to specify the location of my packages. So in my case, that's going to be dprojects packages, and then I'll give it a name -n just to have for easier of reference. I'll name it Play Economy. Okay, so it's been added successfully, and just make sure that you update this location depending on where you send your packages in the previous step. The next thing that I'd like to do, and I'll collapse this a bit, is to go to our Play Catalog Service CS_prog. And what I'm doing is I'll actually remove this MongoDB driver reference, because now everything MongoDB is actually referenced and brought in via the NuGet package. So we will not need to have an explicit reference to MongoDB driver here. So I'll just remove that. And now save this project. And now we can go ahead and add our play.common reference. So to do that, let me switch to SRC. Let's go to play.catalog service. And then we can do .NET add package play.common. Enter. And the reference has been added, as you can see right here. So with that, it is time to start cleaning up things. So I'll go ahead and close my terminal, and I'll close this. And a bunch of things that we can remove now are the iEntity interface. Can remove. Our entire repositories directory can be removed. And our settings directory can also be removed. Okay, so now it's time to fix our imports. So let's go to item.cs and make sure it can find that iEntity now lives under play.common from NuGet package. In our controller, also the iRepository interface now is coming from play.common, and we'll remove this old namespace. And finally, in startup, let's get rid of these old namespaces. Let's actually clean up the entire thing. Remove all necessary usings. And service settings is now going to be coming from play.common.settings. Also, our add_mongo extension method is also coming now from play.common.mongodb. And that's all it is. So we are now completely using our NuGet package. I'll make sure everything is building via Ctrl+Shift+P. Yep, it's building just fine. And now let's test if the service is running properly. So I'll do F5 to run our service. and I'll go to Postman. And I'll just go ahead and do a simple query for all the items in the database via our items operation in the REST API. I'll hit send. And here we are. We are retrieving items from the database. So everything is working properly. So it works just as before, but now, as you can see, and I'll just stop this. Our code base is much simpler. So we don't have the entities interface here. We don't have the repositories folder. We don't have the settings folder anymore. And yeah, our startup looks very clean. And so this is going to help us a lot for the construction of our future microservices. In the next lesson, we will learn about Docker Compose and how it can help us simplify the way we configure and start our infrastructure services. In this lesson, we will learn about Docker Compose and how it can help us simplify the way we run our infrastructure services. We already started using Docker to run our MongoDB database, and we are doing this via a simple docker run command. However, starting with the next module, we will need to start bringing in many other infrastructure services to support our microservices. For instance, in the next module, we will use RabbitMQ as our message broker. And in future modules, we will use Sec, Prometheus, and Grafana to enable a series of observability-related components. So, if we keep just using Docker Run to execute our infrastructure services, we will have to perform too many steps to set up them, and we will need to remember too many arguments for each of them, like the right environment variables, ports, and volumes. Also, some of our containers might need to talk to each other, like Grafana and Prometheus, and some of them might not be able to work at all without another container be up and running first, which again is the case of Grafana, which won't be able to do much without Prometheus being available first. That's where Docker Compose comes into play. Compose is a tool for defining and running multi-container Docker applications. We will now be able to define all of our infrastructure services in a single file called the Docker Compose YAML file. This will include the definition of the container to use in each case, environment variables, ports, and even dependencies between them. Then, we will execute a single Docker Compose up command, and all the containers will start in the right order with the correct configurations. Also, Compose provides a default network that all containers are joined to in case they need to talk to each other. So, with Docker Compose, we are able to document the way to configure all of our infrastructure services in a single file, and we get to start all of them with just one line, as opposed to multiple commands. Also, they all join a default network. In the next lesson, we will create our Docker Compose file and move our current MongoDB configuration over there. Before we start using Docker Compose, let's first create a new directory where we can place the Compose YAML file and any future infrastructure-related files. So here I am in a new Visual Studio Code instance. I have opened my terminal and I am switched into the projects directory. So in this directory, I'm going to create a new folder. I'm going to call it play.infra. And now I'm going to open it in Visual Studio Code. And the first thing that I'd like to do here is to take advantage of the another extension for Visual Studio Code, which is the Docker extension, which we can find if we go to extensions, let's type Docker, it's this one here, because this one is going to provide us some good recommendations as we start working in our Docker Compose file. So I'm going to install this extension, click install, and that will show up a new icon on the left side, Docker. So let's close this and let's go back to our Explorer. Now what we can do is just go back here and let's create a new file. Let's call it docker compose.yaml. And before writing any code here, what I'd like to do is to bring in that previous docker run command line that we've been using, just to keep it as a reference as we start writing this Docker Compose file. Okay, so remember this line that I just pasted. This is what we've been using so far to kick off our Mongo container. So the first thing that we want to do in this Docker Compose file is to define a version for it. The version determines what features you're going to have available in Docker Compose, because different versions of the Docker Compose engine support different versions. So you have to define what version is this file for. So I'll say version. It's going to be 3.8 is the last one, the latest one available as I'm recording this lesson. And the next section is what we call services. The services will determine, each of these services is really one of our Docker containers. So I'll define a services section. And under services, you want to define our first service, which is, in our case, is going to be MongoDB. So I'll just name it Mongo. And as I start writing this, notice the indentation that I'm setting between each of these elements. Indentation is important because it defines which elements go inside other elements. But to make this more easier to see for you, what I'll do is I'll enable another setting in Visual Studio Code so we can see the white spaces that are happening across the place. So I'll go to File, Preferences, Settings, and I'll look for Render White Space. Yeah, so it's this one here. So I'll switch from Selection into All. Then I'll close this. And now we can see the white space right there. Yeah, so as you work on this file, just make sure that you're leaving the same amount of white spaces or indentation with the different elements that we're going to write. I will also collapse this left side, the navigation pane, since we don't need it for now, so we can have more space. So inside the Mongo element, we're going to open yet another element. We have to define the properties for this service. So the first thing we're going to define is the image. And as you remember from the command line on the top, the image is Mongo. So I'll grab that. Then we have to give a name to this container. So the container is going to start up. So I'll say container name, and the name that we've been giving over here is Mongo. So let's use the same name. It's going to be Mongo. The next thing is the ports. So ports is actually an array of ports. So the array you can define by placing a dash first, and then you specify the port mapping. So I'll grab that port mapping from here. As you remember, port is 27017, external port on the left side, internal port on the right side. And the next thing that we have to define is a section for our volumes, because remember that we need to map the /data/db directory inside the MongoDB container into a location outside of the host where the files are actually going to be written. That's what we call a volume. So to define volumes, I'm going to go all the way here at the same level as our services section over there. Here we're going to declare a section called volumes. And under volumes, I'm going to define our MongoDB data section, which I'm actually going to copy over here. MongoDB data, column. And that's really all you have to do to define one volume in your machine. And now we have to associate that volume to our Mongo service over there. So I'm going to open yet another section here called volumes under ports. And under volumes, you have to define an array of all the volumes that you want for this service. So an array starts with dash, and then you define that volume mapping. So I'm going to copy this again. There. So that defines so /data/db is mapped into MongoDB data. Remember that we have to do this because otherwise our database files will be lost if we restart the container. So from here on, anytime that the MongoDB container tries to write to /data/db, those files are actually going to be written into the MongoDB data volume that's outside of the container and into our host machine. Okay, so now I'll save this file. And it's time to start running this container via Docker Compose. So I'll open my terminal, Ctrl J. And the first thing I'd like to do here is make sure that I am not running MongoDB container already. So let's see, Docker PS. Docker PS. And so we are indeed running it already. We don't want to have it running there because that could cause conflicts. So I'll just go ahead and stop it. Docker stop Mongo. Okay, and now it has been stopped. So with that done, we can go ahead and start our Docker container via Docker Compose, and we can do Docker Compose up, hit enter, and then that starts running the container. And what you're seeing now is just the output of the MongoDB container being generated directly into the terminal. So now that we have Docker Compose running our MongoDB Docker container, let's see how is our catalog API working with this new way of running the container. So I'm going to go back to our catalog microservice, and I'm just going to hit F5 to get things started. Okay, with the host up and running, let's go ahead and open Postman, and let's go ahead and try to get all of items in the database. So here I am in my get operation for the REST API. So I'll hit send. And interestingly, I'm not getting any items, which is interesting because as per our previous lessons, we did have at least one item already stored in the database. So what's going on? Let's see, let's go back quickly to Visual Studio Code catalog, and let's explore our database at this point in time. So I'll collapse this a little bit, and let's go to the MongoDB extension, and here's our localhost 27017. I'll connect to it, and the interesting piece here, and I'll collapse these other pieces, is that we don't have a catalog database anymore. And this is happening because as we moved into Docker Compose, a new volume has been created for our database files. So technically, this is a brand new database, which has no items yet, right? So there's actually nothing in there, so there has not been any need to create a database yet. So that's why you don't see any database here. So just keep that in mind as you switch from a raw Docker execution into Docker Compose, a new volume will be created. So let's actually come up with something for our catalog database. So I'll go back to Postman, and I'll go to my Post tab, body. Okay, and so let's again define something here. We'll go again to our Potion example. So it's a Potion, and it stores a small amount of HTTP, and the price is going to be just 5. So go ahead and send this, and the item has been created. So if we go back to our get items API once again, hit send, the item is there. And if we go back to Visual Studio Code to catalog and we refresh this, you can see that now we have our catalog database with our items collection and the one document already created in there. And one last tip that I want to give you as you start working with Docker Compose is how to prevent, let me actually open Docker Compose, how to prevent all this output to be shown here. So in case that you don't want to see all this output from the database all the time, you can see things in a much cleaner way by doing the following. So I'll go back here to my terminal, I'll just hit Control-C to stop Docker Compose. And what you can do is, you can do Docker Compose up, but you can append the -d parameter to run in detached mode. So if I do enter now, the only thing that you're going to see is that it's starting Mongo, and then it says done. So the container is running in the background, but you don't have to be looking at all the output all the time. So it's running in a detached mode. And still, if you go back to Postman and you query, you can see that the container is actually running. So we have reached the end of this module with a few improvements to our developer workflow, and with a reusable library that will speed up the construction of our future microservices. In the next module, we will introduce our second microservice, and we will learn about the multiple challenges of having microservices talk to each other. In this module, you will learn about the different microservice communication styles, and then you will learn about a few techniques to properly implement synchronous inter-service communication between the existing catalog service and a new inventory service. By the end of this module, you will have a solid understanding of the following: the different microservice communication styles, how to implement synchronous communication between two services via REST and the HTTP protocol, what kind of partial failures could impact your microservices and why you should design for them, how to set timeouts to fail fast when doing inter-service communication, what is and how to implement the retries with exponential backoff technique, and when to use and how to implement the circuit breaker pattern. In terms of our overall system design, in this model you will build your second microservice, the inventory service, which owns the player's inventory back. We will use everything we learned in previous lessons and our reusable common library to build this new microservice much faster than when we built our first service. Then we will let inventory talk to catalog synchronously using several techniques for resilient communication. Let's move on to the first lesson. In this lesson, we will create our inventory microservice, which owns the player's inventory of purchased items. Just like we did with the catalog service, we will define a REST API for inventory with a couple of operations, which are post items, which will be used to add an item to the player's inventory bag, and get items by user ID, which should retrieve all the items for the specified player or user. Talking about users, you may have noticed that we have not properly introduced the concept of players or in general users into our system. This is fine. The management of the actual users database will be the responsibility of the identity service, which we will create in a future model, along with all the microservices security infrastructure. For now, we will use random GUIDs to identify the users that own the inventory items. Let's get started. It's time to spin up a new project for our inventory microservice. The process is exactly the same as we did with our catalog microservice, but this time, to make things quicker, we won't create it from scratch, but instead we will use the starter project files I have attached to this lesson in the play.inventory.start zip file just under this video. Please download the zip file and extract it into a location in your box. In my case, I have already downloaded the file into my projects directory, as you can see, it's right here. So I'm going to go ahead and just extract the files. File contents, I'll just extract. So it's right here. So I'm going to delete the zip file. And I'm just going to rename this directory as play.inventory. So this one here, from here on, is going to become our starter inventory microservice. So having done that, what I'm going to do is just go back into Visual Studio Code over here. So this is a new instance of Visual Studio Code where I'm going to open up that folder that we just extracted. So I'm going to click on File, Open Folder, and I'm going to go into my D drive and Projects directory. I'll pick Play.inventory and I'll click on Select Folder. So now Visual Studio Code has opened in the context of the Play.inventory directory. Now right away, Visual Studio Code wants to restore the dependencies of the projects included in this directory. So I'll just click on Restore, and that will bring back any missing dependencies of the project. Now you may wonder what is different here as compared to the catalog microservice. Well, really, there's not much difference. One difference would be, of course, let me close this, the namespaces used here. So because everything is now play.inventory.something something, right? But really the main difference you're going to find is in the, if you go to properties, launch settings.json file. Remember that this is the file where we define a bunch of things, but the main thing is the ports that are going to be used by the application. And so in this case, what we have is a different set of ports for this microservice. So if you see here, the application URL is now in port 5005 for HTTPS and port 5004 for HTTP, okay, which is different from ports 5001 and 5000 that we're using for the catalog microservice. You have to make sure that you never reuse the same ports for different microservices because that's just not going to work in your own box. Right, and now that we have that, what we want to do is start moving on with the additional files needed in our inventory microservice. So what I'm going to do is just go into the play.inventory.service folder over here, and I click over there, and I'll just say new file, and we're going to name this file dtos.cs. Here I'll declare our namespace. The namespace is going to be play.inventory.service.dtos. And so we're going to define two DTOs at this point. The first one is going to be the DTO used to grant items to a user. And the other one is going to be the DTO used to return the series of items that a user already has in their inventory. So let's start by defining public record grant items DTO. And to grant an item to a user, we obviously need to specify the ID of the user. So it's going to be a GUID user ID. Let's add the system namespace there. We also have to specify which is the item, the catalog item that's going to be assigned. So we will define that as catalog item ID. And lastly, we have to specify how much of the item is going to be assigned to the user. So that's going to be the quantity. Let's now define the other DTO as public record. This is going to be inventory item DTO. Like I said, this is the DTO used to return items, the items that are assigned to a user in the user's inventory. So for this, we're going to be returning the catalog item ID, the quantity, and also let's define the acquired date. So this is the date when the item was put into the user's inventory. So now that we have our DTOs, it is time to start defining the entities that we're going to be using to store the inventory items into the database. However, before we can do that, we have to bring in our play.com NuGet package so that we can start using the bunch of classes and types that we have defined there, including our iItems, our iEntity interface. So to do that, I'll go ahead and do Ctrl-J to open my terminal. And I'll go to play.that inventory service, and then I'll just do .NET add package play.common. Okay, so if we go now to play inventory service, we'll see that we have the NuGet package added here. Now we can go ahead and right click in play inventory service, new folder, entities, and let's go ahead and define a new file. It's going to be inventory item.cs. Let's define our namespace. It's going to be play.inventory service entities. Let's define the class, public class inventory item. And let's make this class right away implement our iEntity interface. Let's make it use play.common namespace. And as we're implementing that interface, let's do Ctrl- implement interface. So we have to define a GUID. So public GUID ID. We'll make it define just a get. It will use a get and set, just like that. Okay, so each inventory item will have an ID. Then it should know to which user it belongs to. So let's do prop GUID. It's going to be user ID. Next, let's define which catalog item this inventory item corresponds to, a reference to the catalog item. So it's going to be prop GUID catalog item ID. Next, we'll define the quantity. It's going to be the quantity, how much of this item we have. Let me also close this terminal now. And lastly, let's define datetime of set. Is going to be the acquired date, the date when the item was assigned to the user in the inventory. Save that. And just like we did with catalog, let's define an extension method so that we can transform one of these inventory items into the inventory item DTO. So I go ahead to the root, play inventory service. I'll add a new file. I'll call it extensions. Let's add a namespace. Play that inventory, that service. And let's add public static class extensions. And let's define our method here. So public static is going to return an inventory item DTO. Let's call it as DTO. And let's import the missing namespace. And it is going to be extending inventory item. Inventory item. Let's import that. It's going to be the item. And here it is just about creating a brand new item DTO out of this item. So we will say return new inventory item DTO with item that catalog item ID, item dot quantity, and item dot acquire date. So that's all we have to do to transform the item entity into an item DTO. Now we can go ahead and create our controller. So let's go to the controllers folder, right click, new file. We'll name it items controller, just like we did in catalog. Let's define a namespace for it. Okay, inventory service controllers. It's going to be public class items controller. And remember, each of our items controllers should be marked with the API controller attribute. It should derive from controller base. And it should define the base route that is going to be mapped to. So route, this route, just like with catalog, is also going to be items, just because it also manages items. So route items. So now we're going to need one class level variable here, which is going to be the repository that we're going to be using to store and retrieve items. So let's define a private read-only. It's going to be a repository of type inventory item. And let's just name it items repository. So let's import play common here. And let's import play inventory service entities. Let's also collapse this navigation pane for now, since we are not going to be using it for a bit. And now we have to do dependency injection to actually receive this items repository into the controller. So let's define a constructor. Okay, so this constructor is going to receive again our repository. So I'll just copy that here, item repository, and let's assign it to our local instance, item repository. So now it's time to define our two operations. Remember, we need an operation to get all the items in the inventory and one operation to put an item or to create an item into the inventory. So let's start with the get operation. Let's define that as public async task of action result. And this is going to be of an IEnumerable of inventory item DTO. And then we'll name it just getAsync. GetAsync, and the parameter is going to be the user ID. So we want to get all the items in a user's inventory. So we're going to receive GUID user ID. Okay, let's see, let's add any missing namespaces, reading tasks, systems collection generic, and service DTOs, and for the GUID using system. Let's also define the verb that is associated to this API, which is going to be HTTP GET. And so the way that this API is going to work, this operation is going to work, is we just need to go ahead and get all the items based on the user. So, but before we can do that, let's do a quick check. Just make sure that this user ID is not empty. So if it is a GUID empty, we're going to return a bad request. Bad request, a simple validation in there. And so to get the items, we're going to do this. So we'll say, so the items is going to be, and we're going to open a braces here. We're going to do an async call to items repository, get all async. And here's where we can start using our expression, our filter based on an expression. So in this case, what we want to say is that we want to get any item where item.userID equals the user ID that we got as a parameter over here. Okay, so that's how we can filter items based on a user in this case. And then when we have that, we can do a select. Let's see if I'm missing another namespace, system link, where we're going to specify that we want to take each of these items that we found in the database and transform them as into a DTO with our extension method. And finally, we'll go ahead and just say return the items. Let's also transform this. Let's wrap this into the OK, into the OK action result. And that's all we have to do. So that will return all the items in the user's inventory. The next method is the one that we're going to use to assign one item to the inventory. This is going to be a post operation. So let's see. Let's define it as public async task. We will just do action result. We're not returning really anything out of this method. Going to be post async, and it's going to be receiving our grant items DTO. Items DTO. Let's mark this with the HTTP post verb. Here what we're going to do is we will try to find if we have that inventory item already assigned in the inventory, because it could already have it. So in which case we just need to increase the quantity. Or in the other case where we don't have it, we just have to create it for the first time in the inventory. So let's try to find it. So we'll do, so it's going to be inventory item equals await items repository get async. And again, here's where we can use the expression filter, where we're going to say that the item that we're going to try to find has to be one where the item that user ID has to match the grant items DTO user ID, and also the item that catalog item ID has to match grant items DTO catalog item ID. Let me see if I can put this in the next line. So that will find the item if it is there. So, but if the inventory item happens to be null, this is the first time that we assign this item to the user. So in that case, we will go ahead and say inventory item equals new inventory item. And we will set its catalog item ID is grant items DTO.catalog item ID. The user ID is grant items DTO.user ID. The quantity is that quantity. And for acquired date, we will just set our current datetime offset. So it's going to be datetime offset.UTC now. And finally, we will call our method in items repository to create an item. So create async inventory item. Okay, let's add this missing semicolon there. And then let's go for the other branch. So else, we did find the item, so we just need to increase the quantity. So for that, we will do inventory item.quantity plus equals grant items DTO.quantity. And then we will do await items repository that update async with the inventory item. And finally, we will just return OK. Yep. And that's pretty much for the controller operation. So we have two operations to retrieve the items in the inventory and to put an item into the inventory. So with that done, it is time to start doing the basic configuration of a startup. So I'll go back to our Explorer here. And first, let's go to app-settings.json. Here we have to define the settings for in order to define the service name and the MongoDB connection. So to save time, what I'll do is I'll go back to catalog actually, and I'll open my app settings JSON file over there, and I'll just copy these two sections from the app settings JSON. I'll go back to inventory and I'll paste that right here. Really the main thing, the only thing that we have to change here is that this is not the catalog service anymore. This is the inventory service. Remember that this is what's going to define the name of the database that's going to be created in MongoDB. Save that. And now I'm going to go to startup. I'll actually clean up a bit these namespaces. So I'll do control dot here, remove unnecessary usings. And now I'll go to the start of configure services. And I'll add the services for MongoDB and the repository. So I'll do services.add Mongo. And that may need another import, paycom MongoDB. And then I'll add Mongo repository of type inventory item. Let's add a using there. And here we have to specify the name of the collection here. So the name that we're going to give it is inventory items. Save that. And so with that, we have registered everything related to MongoDB. And we actually are ready to start trying out this microservice. So I'll go ahead and hit F5. Okay. And then what I like to do is actually import the specification of our API into Postman to make our lives a bit easier. What I'll do is I'll copy the URL of our service, localhost 5005. And then I'll go to our browser just for this time, paste that there, and then let's go to Swagger. So this defines, as you can see, this is the Swagger UI page for our REST API. Then I'll click in the swagger.json link here, and I'll copy that. Copy that, and then I'll just close this browser. Now I'll go to Postman. And here what I'll do is I'll just click on import link. I'll paste that. Click continue, and I'll just say import. So now if we go to collections, we have now not just a catalog service section, but also a collection, but also a play inventory service collection with our 2 items related operations. So what I'd like to do is to go ahead and try out our post to assign an item to a user. But of course, before that, we have to define the base URL for for this collection. So let's go to let's go to edit, variables. And in this case, our base URL is, as you remember, let's go to inventory. Base URL is localhost 5005. Put that here. I'll put it for current value and for initial value. Update that. Okay, so it knows the base URL. Now, being in post, we go to body, and here's the 3 things that we need: user ID, catalog item, and quantity. Now, for the user ID, like I said in the introduction, we don't have actual users so far, so we just generate a random one. And one handy way that we can do that in Postman is by using the GUID function that's built into Postman. So what you can do is just this. So open 2 sets of curly braces, and then you're going to do just GUID. So that will on the fly generate a GUID for us. And for the catalog item ID, we want to know the ID of one of our items in the catalog. So to do that, let's actually query our catalog items. But before doing that, let's go back to catalog and just hit F5 to actually start the web server so that we can query the catalog. And then I'll go back to Postman into our play catalog service collection. I'll expand this. I'll go to get items, and I'll just hit send. And here is the one item that we have in the catalog, the potion. So I'll copy this ID. And I'll go back to our post operation, paste it there. And let's say that we want to assign just one of these potion into the user's inventory. So now I'll go ahead and hit send. And we got 200 OK, meaning it was a success. And so to verify that this actually worked, let's actually try out our get all items in the inventory operation. So I'll click on this new operation. And in this case, the first thing that we're going to need is to specify which is the user ID, right? So which user was that item assigned to? which if you go back to post, it was an automatically generated user. We actually don't know yet, but we can figure that out via our console. So I'll click on the console down here, and you open the post operation, and we expand the body, the request body. You see that the user ID is right here. So the console records everything that's going on behind the scenes. So it's pretty handy in these cases. So I'll just copy the user ID, and I'll close this. Then I'll go back to our get items from the inventory service, and I'll paste that right here. So with that, I'll go ahead and hit send, and here it is. So this user has one of the catalog item of this ID, and with this acquired date, the date was assigned. And so let's say that we wanted to increase the quantity of that item for this user, and we want to actually test this other code path. So let's go back to post body, and let's say that we want to add perhaps 4 more potions to this user's inventory. So I'll just do that. We want to change now. We don't want to generate yet another GUID. So I'll replace user ID with the ID that we just copied for our user. So then I'll go ahead and hit send, 200 OK. And then if we get items for this user in inventory, I'll hit send. And now the quantity is 5. So now the user has 5 items in his inventory. Okay. So at this point, our inventory service can store and report the items that each user has in his inventory bag. However, notice that this DTO that we have returned by the get operation only provides the IDs of the items in the user inventory. So since we don't have any names or descriptions, it is a bit hard to tell which items are in the user inventory, which are the actual. So what does 4E9C means really? So in the next lesson, we will learn about microservice communication styles and how our inventory service can use them to retrieve more details about each of these items from the catalog service.